Hi friends, welcome to my channel NM Learn My Courses with Nagmani. Today we are going to solve this problem. Okay, so this beam which having hinge support and roller support which having uniformly varying load, which is nothing but trapezoidally distributed load, and it having x and y forces in x direction with the 0.5 meters each side of this beam. And here we have one inclined support. If you solve this problem, you can solve any type of problem. Okay, and please listen carefully. So before going to solve this problem, we have to draw free body diagram. So I am writing free body diagram. I am drawing free body diagram here. Okay, so here we have hinge support. So it has two reaction forces, one in x direction and another is in y direction. So x direction is RAX, reaction force at point A. In x direction, reaction force at point A in y direction. And here we have roller support which have only one vertical reaction force. Okay, if you see here, this is the 2 meter length. So here we having trapezoidally distributed load. So if you see here, to converting this into point load, so this can be classified into two types. Here if you draw a section from this point to here, this is below this line is uniformly distributed load, and above this line is triangularly distributed load. So for uniformly distributed load, the load will act at the center of this length. So for 2 meter, the center is at 1 meter. So at 1 meter, the load will act. The load which is equal to this height is into this length. So 10 into 2, 20 kilonewtons of load is acting. So here meter is there, so 2 meter, here 2 meter is there, so meter get cancelled, we will get 20 kilonewtons. And now if you see this triangularly distributed load, the load will act at the centroid of this one. So centroid of triangularly distributed load is L by 3. That means here total is 2 meter length at 2 by 3 length. So here we have, this is 1 meter and this is also 1 meter. So 2 by 3 means, so from here to some here, this is 2 by 3. At 2 by 3, the load will act, which is equal to half into area of that. So here we have total, this much is 20 kilonewton meter. So this side is we have 10 kilonewton per meter. So we need only this much of height. So this much of height. So we have to subtract from each other. So 20 minus 10. 10. So 20 minus 10, which is equal to 10. So 10 into this length, which is 2 meter. So we will get from here 10 kilonewton. Understood? So for a trapezoidally distributed load, two loads will be acted. So one is if you see here, one is uniformly distributed load and one is due to triangularly distributed load. So for triangularly distributed load, the load will act from the base 2 by 3 from here. So and the next one is uniformly distributed load, the load will act at the center of this length. Okay, and here they are given two loads. So for this we have to know the transferring loads, some concept you have to know. So I will explain here. Okay, next first we will write the here. So this one is at 1 meter. So this one is at 1.5 meter. This is also 1.5 meter. So we know that for a components division, here we have 25 now. So 25 cos 60, here 25 sin 60. Okay, and for here shifting loads, so here they are given. So I am writing here, see, this is the beam AB and here the loads are there. One is acting 5 kilonewtons, and another one is also this one is 2 kilonewtons. So this one is 2 kilonewtons at 0.5 meter above and below also 0.5 meter. So for shifting these loads to here, whenever if we write for only, we will see above, only above. Here we have 5 kilonewtons load. So at this point, if we write 5 kilonewtons and this side also 5 kilonewtons, so this one and this force will get cancelled and it will be neutral. So there is no change. So I am adding 5 kilonewtons load this side and 5 kilonewtons load this side. So if you see here, if we write this, if we neglect this one, this point is 5 kilonewtons and here we have 5 kilonewtons. So if you see here, it making momentum like 5 into this perpendicular distance is 0.5. 5 into 0.5, which is equal to 2.5 kilonewton meters of moment is acting in this clockwise direction. Understood? In this way, and here we have one extra force. So I am writing here, see. So we have this 5 kilonewtons of force and here we have momentum, that is 2.5 kilonewton meter. So in this way we can convert the load, we can transfer load from one point to here, and due to this effect we from here we have that movement. And similarly, if you see 2 kilonewtons, so I am redrawing here. Here we have 2 kilonewtons of force, here 0.5 meter. So here I am adding 2 kilonewtons of load. Here also I am adding 2 kilonewtons of load. So this one will get cancelled. So which is neutral. So there is no effect on adding 2 kilonewtons on both sides. So I am shifting this load to here. That means I am keeping this load as it is, and here 2 kilonewtons of load is there. Here also 2 kilonewtons of load there at 0.5 distance. So if you see here, this is making in clockwise direction, momentum is acting. So from due to these two loads, so 2 into 0.5 meter, which is equal to 1 kilonewton meter movement is acting in this direction. 1 kilonewton meter this movement is acting. Here we have 2 kilonewtons of force extra, so that one we have to write here 2 kilonewtons. Okay, in this way we can shift the loads. Understood? Okay, I will redraw here again for the clear understanding. Here we have, so we have here RAX and RAY. Okay, this is a point. Here at 2 by 3, so 2 by 3 means 0.66. So 2 by 3 we have load, that is 10 kilonewtons, and at 1, so at 1 we have 20 kilonewtons of force. So from here to here is 1 meter. So I am writing here again 1 meter, and here to somewhere 1 meter. Total is 2 meter. Okay, and after that a 2 meter load is, this one is completed. Next one is at this point at 1 meter. So at 1 meter we have this side 2 kilonewtons of force, this side also 5 kilonewtons of load, and at this point we have 2.5 kilonewtons of movement, and this side we have 1 kilonewton meters of momentum. And at this point, so at 1.5 meter we have, this one is 25 cos 60, no? So 25 cos 60, which is equal to 12.5. So which is equal to 12.5 kilonewtons. And in y direction I am writing in above here. Okay, 25 cos 60. So 25 into sin 60, no? Sin 60, which is equal to 21.65 kilonewtons. And here we have RB. This distance is 1.5 meters. So in this way we can write the loads everywhere here. So for shifting of loads, if you have any doubts, this is shifting of loads. If you have any doubts, I will explain at the end of this class. If you want, you can listen after this class. Okay, now we are going to solve this problem. Okay, so this is the free body diagram for given problem. So for solving, we have to we know that statically equilibrium equations, that is sigma forces acting in the x direction is 0, and sigma forces acting in y direction is 0, and sigma moments its point equal to 0. So from one, that is sum of the forces acting in x direction equal to 0. So in this problem also I am solving with the whatever the forces in acting in upward direction, which is equal to sum of the forces acting in downward direction. So with the help of this sign, I am going to write with the help of this one. So forces acting in upward is RAY is there, and only RB is there. So RAY, so sorry, this one is x direction, this is for y. So sorry, I'm so sorry. For x direction, sum of the forces acting in positive x direction, which is equal to sum of the forces acting in minus x direction. So for y, sum of the forces acting in upward y direction, sum of the forces acting in downward y direction. In this way we have to write the equations. So forces acting in positive x direction is RAX, and here we have, so we will write one by one. Here RAX is there, and in positive x direction is 5 kilonewton is there, and here 12.5 plus 12 kilonewtons is there, and there is no other force, which is equal to sum of the force acting in minus x direction, that is 2 kilonewtons. Okay, here we have 2 kilonewtons of force, no need to write kilonewtons now. And now from this equation we got RAX, which is equal to 12 plus 5 is 17.5 minus 2. So we get 17.5 minus 2 is nothing but 15.5. Okay, RAX is equal to minus 15.5 kilonewtons. In this way we can find the reaction force at A point. Next one is sum of the forces acting in y direction equal to 0. So from this equation I am writing sum of the forces acting in upward direction, which is equal to sum of the forces acting in downward direction. I am equating like this. So force acting in upward direction is RAY. So RAY plus RB, which is equal to force acting in downward, which is 10 kilonewtons. Next one is 20, and next downward force is, there is no downward force, here is 21 plus 21.65. So if we add all these, we will get 20 plus 10 30, 30 plus 21 51.65 kilonewtons. Here we got one equations. So from moments we can write moment acting in clockwise direction, which is equal to moment acting in clockwise direction, anti-clockwise direction. So from here I am going to write, so third one is sum of the moment acting at, I am taking at point A, moment at point A equal to 0. So moment acting in clockwise direction, which is equal to sum of the moments acting in anti-clockwise direction. So sum of the moment at point A equal to 0. I took this equation, so I am equating with moments acting in clockwise direction, which is equal to moment acting in anti-clockwise direction. So if you see here, I am taking moment at point A. So here 10 into the perpendicular distance is 2 by 3. 10 into 2 by 3, which is acting in, here we have to take from, this is downward direction. So the moment acting in this way. So here to like this way means clockwise direction. So for clockwise direction 10 into 2 by 3. 10 into 2 by 3 plus here also 20 also downward force from here to here. 20 into this is 1 meter distance, perpendicular distance, 20 into 1. And next one is here, if you see direct movement here, which is acting, both are acting in clockwise direction only. So this one is acting in so this is also acting in clockwise direction, this is also acting in clockwise direction. So plus 2, so here plus 5, and next one is from here 21.65 into this distance, so 2 meter, 3 meter, 3 plus 1.5, 4.5. So 21.65 into 4.5, and this one is which is collinear, so there is no movement from this force. And next one is this one, so which is equal to RB into the perpendicular distance is 2 plus 1 3, 3 plus 1 4, 4.5 plus 1.5, 4.5, 5, 6, so 6. So from this equation we are going to find RB value. So I am writing above, which is RB equal to, so here I am adding everything here whatever is there, 10 into 2 by 3, so 10 into 2 by 3 plus 20 into 1 is nothing but 20 plus 2 plus 5 is 7 plus 21.65 into 4.5. So we are getting this much value divided by 6. So divided by 6. We got this much. For decimal we have to click this one. So 21.85. We got 21.85 kilonewtons of force RB. So if we substitute RB in this equation, we get RA by, if RB equal to 21.85 kilonewtons, then so RA by, which is equal to 51.65 na? So 51.65 minus 21.85, sorry 21.85, we will get 29.8 kilonewtons of force. So in this way we got reaction forces at A and B, and we have to find the coordinate forces, we have to find the resultant force. So whatever the results we got from those equations I wrote here, and I draw the diagram of that to represent RA and RB. Okay, and first we have to find the, from these two equations we have to find the resultant force, that is RA equal to and the root of RAX whole square, that means minus 15.5 whole square plus 29.8 whole square, which is equal to, so the root of minus 15.5 whole square plus 29.8 whole square, so which is equal to 33.59 kilonewtons. Okay, don't forget to mention minus inside only. If you kept minus outside you will get different answer, so don't forget that. And for finding the direction, theta equal to tan inverse of RAY by, RAY is 29.8, modulus of this one na, so modulus means positive, so 15.5. We will get tan inverse means shift plus tan, will get tan inverse, then 29.8 divided by 15.5, we will get 62.52 degrees. Okay, in this way we can find the direction. So RA equal to 33.59 means 636 kilonewtons, 33.6 kilonewtons with the angle theta equal to 62.52 degrees, and RB which is equal to 21.85 kilonewtons. In this way we can find the reaction forces, reaction forces at the given support. And if you understand the problem, please like, share and subscribe to my channel. And I told you that how to shift these forces, no? So if you want, you can continue this video. So for shifting these forces, if we if we consider one beam like this, so for this beam the force is acting here at some distance, okay. Here same I am taking here only, so which is 0.5 meter distance. The load is acting is 5 kilonewtons of load is acting this direction, and 2 kilonewtons of load is acting in negative x direction at 0.5 meters from the same from the x-axis, okay. So for shifting this load to here, we need to shift this load to, because this is the beam, so we have to show the whatever the force is acting on beam only we have to show. So this force is acting above this beam. Because of this force it will create movement, so we will see now. So if I write line axis line here, at this point we have only 5 kilonewtons force. Let's assume that only 5 kilonewtons for it from the distance 0.5 meters. So for converting this, for transferring this load to axis load, so we have to make two equal and opposite forces which having same magnitude. So 5 kilonewtons, here also 5 kilonewtons. So this load opposite this load is there, so because of this load and this load it will create movement, okay. 5 kilonewtons, which is distance from this point is 0.5. So for movement force into this perpendicular distance, so 0.5, 5 into 0.5 which is equal to 2.5 kilonewton. This is meter. This is the movement which is caused due to this one. So this point is cancelled, this point is cancelled. Now I am writing here. Here we have from these two loads we got momentum as 5 is a 25, so 2.5 kilonewton meter of load is acting, and one force is acting at this point, so that load is we are representing here. So in this way we can shift the loads to the axis point. So similarly here also we have 2 kilonewtons of force. So for that if we draw the axis line, so here we have 2 kilonewtons of load. So with this 0.5 meters distance, so we have to draw 2 kilonewtons of force this side and 2 kilonewtons of force this side. So because of this load and this load, which causing like this is no, which causing movement at this point, so in clockwise direction. So I am writing here, because of that 2 kilonewtons of force is acting, this force is this side 2 kilonewtons. So in this way we can shift the forces that I have shown in free body diagram. In this way we can shift the loads. If you want more classes on this topic, please comment below, and if you have any doubts also please feel free to ask. And thank you for watching. If you really feel these classes are helpful to you, please like and share, subscribe to my channel.